So today's webinar, which is delivered in collaboration with the Association for Science Education, will explore what it means to create an inclusive science classroom, and it will discuss the benefits and impact of inclusion with a specific focus on linguistic inclusion and the development of the language of science. And we've got two speakers presenting today, whom I'm very excited to introduce. We've got Dr. Yasmin Mortuza, from the Association for Science Education, and Sheila Hopkins from the Bell Foundation. And Yasmin is an inclusion in science consultant for the Association for Science Education. She's been in secondary education for over 20 years, including roles as middle leader, senior leader, and educational advisor for several London local authorities. And in addition to supporting the Inclusion in Science program, Yasmin is also currently a teacher developer for the Royal Society of Chemistry and a leadership mentor for teachers studying for the MPQ qualifications and a chair of governors for a primary school. And Sheila Hopkins is a trainer at the Bell Foundation. She has worked as an EAL specialist in primary and secondary settings and as an EAL tutor in initial teacher training and TESOL programs in the United States. Her work with the Bell Foundation focuses on multilingual learners and EAL for initial teacher training, early career teachers, and senior leaders, among many other areas. If you have any questions for either of the speakers during the webinar, please feel free to use the chat option to send any questions as they come to you. I will collect them during the webinar and then I will post them to Yasmin and Sheila at the end. And in the next couple of days, you will receive an email from us with all the links mentioned during the webinar, as well as a recording of the webinar and any resources mentioned today. But enough introductions. It's time to pass over to our first speaker, Dr. Yasmin Mortuza. So over to you, Yasmin.
Thank you so much for the introductions, and also a big thank you to the Bell Foundation for setting up this collaboration with the Association of Science Education. Okay, so as mentioned, one of my roles is I am part of the inclusion team in ASE. So we have a very broad interpretation of inclusion. And for my short section, which is about 15 minutes, I will cover a few things about inclusion, our interpretation of inclusion. I will work through one case study, if you like, or one scenario where we look at the relationship between inclusion and EAL learners, and then we'll have a little bit more of a slightly more deep look at collaborative learning and how that impacts on inclusion and language as well. Okay, so inclusion, you know, in schools, you probably come across all kinds of different interpretations of EDI, equality, diversity, and inclusion. And also, you probably have a particular definition of inclusion as well, which in the majority of schools sometimes pertains to SEN or SEND students. Our interpretation of inclusion is much, much broader, and we like the organization that our interpretation most aligns with is this UNESCO definition, where they say that a dynamic approach to responding positively to pupil diversity and of seeing individual differences not as problems but as opportunities for enriching learning. So hopefully that is something that lends itself to EAL learners as well. So their linguistic differences, we can see them as opportunities for enriching learning on top of everything else. So I just want to share that with you, so a little bit about our philosophy, if you like. So why is inclusion important for EAL learners? So I've fished out a few, key messages, if you like, from this publication that's shown on the screen. Some of these key informations will be shared. Thank you, Shaka, for offering to share links in the chat as they go. And as mentioned, these will also be sent to you at a later point. So don't panic too much if you don't get your hands on the links, but they will be popping up on your screen as needed. So from this bedrock Bedrock publication. They came up with 4 reasons, and before these pop up on your screen, what you'll find is that these reasons lead to, one directly contributing towards the other as to why inclusion for EAL learners is important, because it can be potentially a compounding issue, if you like. So the first one is cultural barriers. So if students are lacking language, or that language is not scaffolded, the immediate impact is going to be the cultural barriers, because then they're going to experience a very different environment of learning, which prevents them from fully expressing their skills, not only their academic skills, but actually socially as well. And this can lead to all kinds of potential misunderstanding, unfair expectations, etc. So they are experiencing a different environment, a different learning environment, if they don't have the same language. This, of course, will translate, or can translate, into actual learning loss. So this is where the students, if they don't have a strong English language skills during their school years, of course, they're not going to learn as much as those who have a much stronger command of English. And that, of course, will lead to, can lead to, I shouldn't say will lead to, but can lead to lower academic attainment. So it is converting over into performance figures. And for students, that's going to take the shape of test scores, GCSE scores, etc. And the impact can carry on beyond their school life. It can limit their access to higher education and employment, as particularly those things that require qualifications to get there, but also linked to going all the way back to cultural barriers, and that those linguistic skills needed that can hold back on the confidence that students would need to access all of those things. So it's very important. Moving on. Okay, now at ASE, I just mentioned to you earlier that we have a very broad definition of inclusion, and that extends to our understanding of how language impacts on learning for students as well. So if I just take this broad saying from Gary Obin, who's an expert around SEND. So he actually, I'll go quiet for a minute to give you a chance to just read the information that's on your screen. So I'll just go completely quiet for a moment. Okay, so I hope I gave you enough time to have a read of that. So what is essentially being said here with the supermarket door example is some people will need those doors to open. It's going to, without that facility in place, they actually won't be able to get into the supermarket. But actually that resource, once it's there, will benefit most people. So in science, we can look at language in that way as well. We know from all different sorts of research that's done that particularly when it comes to GCSE sciences, that the amount of new words that students are learning, including old words, but with a scientific twist, if you like, is so high that it's actually the equivalent of a modern foreign language GCSE. So from that point of view, all students are to a greater or lesser extent EAL students. But of course, then we've got, students who have English literacy barriers, which we cannot ignore. But the main point here is if we take care of our EAL learners, we'll probably bump up science access for everyone. And that's the key point here. Okay, so I'm moving on to a scenario now. So in this scenario, what we have is a teacher, a Key Stage 3 teacher. So this teacher has just demonstrated magnesium burning in a crucible and has weighed the magnesium before and weighed the product afterwards. And so if you're a chemistry teacher, you would know that the product, of course, is magnesium oxide, which is going to weigh more than magnesium, thanks to the oxygen atoms that have combined to make the product. So there's some cognitive conflict there, which we as teachers, we can use that to support the students' learning. That unexpected, students might be surprised that the product weighs more. So if the teacher asks the question to the class after giving that demonstration, what you'll have popping up on your screen in a moment is viewpoints from 8 different students. Now, what you'll see is not their science answer to this question, but rather their barriers to learning. And as these pop up on your screen, what I want you to think about is which of these is directly an EAL issue, and which of these will contribute towards an EAL issue if the student is an EAL and all of these students are EAL, and vice versa. Okay, so have a think. So we're looking at the interplay between inclusion and EAL, if you like. So here it goes. Sorry, I thought they were going to come up one at a time, but they all came up together. So have a little read, and I'll just go quiet again for another moment. Okay, so I hope that some of those ideas there resonate with some of your students. So if we look at, for example, Izzy said, Izzy in the top top left-hand corner rather, I think I know the answer, but I don't want to look stupid if I get it wrong. So a student with any language barriers is more likely to lack that confidence. Okay, so let's look at Olivia towards the bottom, towards the middle, towards the bottom. My TA isn't here today, so I don't know what is going on. So dependence on TA, again, linking to a lack of confidence. But then if you look a little bit at the other end of the spectrum, you've got Marcus. I don't know the answer, but I'm bored and I can't be bothered. So again, looking at the EAL stroke inclusion interplay. Now here, because this is such a short lesson, I want you to just go away with a thought, because what Sheila's going to do later is cover with you some of the strategies that any of these students will benefit from. And that is that what we have here is an exercise. And what we did at ASE was we set this as an exercise for teachers through various online training modules. And we gave them only 10 minutes to come up with solutions for all of these students. And in only 10 minutes, this is the sort of thing they generated. So you can see the yellow stickers are strategies. What strategies would you use to break down these barriers? And the blue stickers are how would you ask the question in a more inclusive way? So the key learning here is that actually what we want is we want to have that knowledge of individual students. And if we sit down and problem solve it, we probably have a lot of solutions within us, within the team, that just needs that time and space for discussion to extract. Okay, and that's very important for EAL students as well. Okay, so moving on. Right, so a little look at collaborative learning. Now, according to the Education Endowment Foundation, because they have lots of facts and figures in their teacher toolkits, collaborative learning adds 5 months equivalent of progress per student per year. Now, if you delve into the data and the learning around this, it turns out that in science, the impact is even bigger. And part of the thinking around this is that collaborative learning is very important because it helps students to unravel abstract ideas. And that's why the impact is this incredibly powerful in science. So that is, if you switch from non-collaborative learning to collaborative learning, or at least have it incorporated into your lessons, then your students can gain potentially 10 months equivalent of progress per student per year. So we're looking at potentially huge progress. So the investment in this will pay off. It's not an easy thing to do necessarily, but the investment will pay off. So a few things about it then. We do, because, you know, collaborative learning, some of us fear it because it can be associated with issues like, will the students go off task if we give them group tasks? Will some students dominate? Will some students become passive? Those are issues to overcome. So we do know that students need to be deliberately supported to participate, particularly SEND students or those with LPA, low prior attainment, is what that means there. We do need to be willing to experiment with the groupings and the pairings. There is no absolute formula that anyone has published that says this type of grouping will always work. There are pros and cons with any strategy that you use to work out how to group the students, but it's something that needs monitoring, observation, and careful consideration, and willingness to be flexible and move the groupings around. We do need to model good practice, so we don't let them loose and say, go away, you've got 5 minutes to do something and then come back. We actually do need to teach them how to work collaboratively, and I'll be sharing 1 or 2 tools with you. This is a huge area that does deserve a good look. And then next, so monitoring. So by monitoring, what monitoring means is that in addition to doing all the usual things that particularly science teachers are good at, which is monitoring progress, we want, in addition to learning progress, we want to monitor progress in how well are students collaborating with each other in order to get tasks done, and to not expect it to happen overnight. So monitor and be ready to intervene. Okay, particularly with those students who are struggling or not participating, not leaving it to chance, and providing students with rules for group talk. There are lots of resources around this, so I'm going to share some of these resources with you now. And I know that Shaka will be putting links up in the chat as well while I talk through this. So this is just one resource that came from National Strategies, and this resource is called Golden Rules for Effective Group Talk. So in fact, it's a 1-page document, and actually the key information is right there. I'm not going to go through it bullet by bullet, other than to fish out a few things. Group work doesn't happen by chance. It does need some planning. So you can see the bullets on the left-hand side are the things to plan for, if you like. Now, during the lesson, there are simple, easy things we can do that's going to make group talk a lot easier. So things like sharing timings. You've got 5 minutes, you've got 2 minutes, you've got 30 seconds, whatever it is, and using countdowns, that type of thing. Ensuring that students are clear about the outcomes of the task. So not just saying, go away and do this, but saying at the end of this talking activity, I will expect you to be able to boom, 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 boom. So that type of thing. Okay, yeah, this is a document well worth downloading and sharing with staff. And the take-home message at the bottom there is group talk is something to be strategically managed and not left to chance. And with that bump up of 10 months per student per year, it's worth that investment. Okay, so this slide, I've just fished out some of the very obvious points. So convey clear expectations about what outcomes to expect. I'm going to very quickly just flash up on your screen a few resources, but maybe the most important thing to share with you is this this link, which is a library of resources. So National Strategies resources, the STEM Learning e-library. They've very kindly collated some of the useful documents regarding collaborative learning, how to manage group talk, that type of thing, and I've put it all in this library. And I'm just going to show you 1 or 2 little things here that will be of interest to you. So recognition board. This is an example of a tool of how to manage and build up collaborative group talking, the students' ability to talk in a group, because let's face it, some students are going to need more support than others. Now you see by the bullets along the left-hand side that some of these bullets are easy to access. Everybody can do it if they're not already doing it. They can, by making the skill explicit, good at active listening, we can ensure that all students are on that first rung of the ladder towards good quality collaborative learning. But you can see that some of the other bullets are much more challenging, such as good at fitting own ideas with others, good at suggesting ways to move a discussion on. So on the right-hand side, you can see the exact same bullets. There are multiple ways you can represent them. So you can actually have a physical poster up on your room somewhere, and the students, you know, to promote their metacognition at the same time, they can maybe write their initials up there when they think they've completed one. Or you can shrink it down and have it as a mini sheet, review sheet, and maybe at the back of their books or something like that. So one other resource. Okay, so how about these for scaffold? So on the placemat on the right-hand side, that's something that can be laminated. I've seen teachers actually laminate them right directly into their tables. I wouldn't recommend that necessarily, but as a laminate that can be taken out and placed on the tables, how about that? There's something for students to quickly look at as they're having a chat with their classmate about something. Roll cards. So this particular roll card has been set up with collaborative work during practical work as the background. So you can create different roll cards for different types of learning. So here, the key thing here is that with the roll cards, each student has a defined role which is associated with a particular skill set. It's very important here to rotate the role so that no one student is permanently stuck in one role, and that they're actually benefiting from rotating. Okay, moving on. So that was my short presentation, and hopefully a little dipping the toe into the world of collaborative learning. I do recommend that you spend half an hour or so in your own time exploring the e-library that I mentioned. So very quickly, just plugging some of our work at ASE. We've got a conference coming up on the 1st of July on inclusion, and we've got an amazing range of speakers, 16 speakers speaking on that day. And it does require for you to be a member to attend, but membership is only £45 per teacher, which is well worth, even if you use it for nothing other than to attend this conference. We think that's well worth it. And on top of that, you get a full year's worth of membership with all kinds of access to science tools and resources online. We are later on today, Shaka will share with you a link. We are gathering information to expand our EDI and inclusion offers. So we are doing consultancy work, and we've got coming up soon a variety of CPD programs to build on our already highly successful CPD programs. And so do watch out for those. So again, links for those will be shared with you, but also if you do have 5 minutes, please do fill in our survey as well. So I think, and the little boy, just to promote those as well. That's what our team looks like. We're a small but very active team. So thank you so much for your time. And again, thank you to the Bell Foundation. And at this point, I will hand over to our next speaker, who is Sheila Hopkins. So over to you, Sheila. I will stop sharing.
Thank you. Okay. Let's see. Oops. Sorry, everyone, just 1 minute here as I get you in line. Okay, does that work? All right, very good. Well, thank you, Yasmin. We have been really happy to partner with the Association of Science Education, and we really admire what they do, especially when it comes to inclusive pedagogy. So as Yasmin mentioned, I am going to continue on now with from the Bell Foundation, and we're going to look at linguistic inclusion for multilingual learners who are learning English as an additional language, and some of the challenges that they find in science language, and then offer some possible ways to support with that. So to begin, I would like to introduce you to Karima. She speaks fluent Arabic and is at a level of developing competency in English. And she thinks, and I'm going to read the quote, that school is where you go to learn a secret language, but they don't tell you that it is there. You have to figure it out on your own. And in certain ways, her sentiment, I believe, can really reflect what many monolingual classmates whose only language is English might also feel. It's somewhat what Yasmin was talking about earlier, that this can support all learners. Unfortunately, the challenging characteristics that we find in science language can at times alienate our learners and actually make them so they don't believe that they can do science or that they don't really want to engage with it, okay? So to understand what Karima means by this secret language, I'd like to have you read two different quotes, and they both describe the impact of human activity on aquatic ecosystems. Now, the first is an oral description from Karima herself, and so you can go ahead and read her quote. Okay, and the second one comes from a text, a science textbook. Go ahead and read this. Okay, well, we can see how the language, what she's talking about, the secret language or whatever, it really was referring to the second text here. And we can see how the language changes based on the situation of use, right? The first text is really oral, it's spontaneous, it's informal. It's probably what we might think of when we think of everyday language or what learners, the language learners might bring to school. The second text, though, is much more formal, it's planned, it's written, it's what we might refer to as school-based language or academic language, okay? And although this second text may sound much more authoritative and scientific and precise in its text there, really important scientific thinking is happening in both of these texts. In fact, using everyday language in the classroom as a way to build up new science concepts really can help students produce clearer and much more complete science understanding. So for multilingual learners, this really includes being able to use home language and other languages that they may know as a resource for learning. Okay, so for example, talking with a partner who may share a common home language, or taking notes and labeling diagrams in their preferred language, or using bilingual dictionaries, translation tools, all of those resources that they have, their own language resources, can be used to build up new learning. And yet, we know that part of doing science at the secondary level really does involve students using discourse that is specific to scientific fields. So the discourse of biology, the discourse of physics compared to chemistry and that type of thing. And it's really not a service to protect multilingual learners like Karima, who are learning English, or any student for that matter, from the more complex demands of scientific language that they're going to need in order to really engage in scientific inquiry. And instead, what we really need to do is to utilize that language to make it visible and to support it in the classroom. Okay. We are not suggesting that science teachers should function as language teachers, but rather as supporters of the demands of language learning that actually occur in a science classroom environment. Okay. So making the language of science more visible to students, though, it first starts with teachers themselves understanding how the language of science works, and to become aware of the linguistic challenges that the science language presents for our students. And addressing this language instead of ignoring it can really have a substantial impact on learner outcomes. So let's get to it in that regard. When we think of supporting language in science, I think we typically think about all those key vocabulary words that are abundant in science, right? And those are really important, but we know they are not the whole thing. And to understand the demands of school-based science, we really need to look further at the sentence level and at the text level as well. And we actually at the Bell Foundation suggest that when you are thinking about what language that needs to be supported in your lessons, that you really start by looking at the text level, okay? Because this provides a big picture of what the content is that you're going to be teaching, the meaning of that, the key messages, and also it gives you a sense of what learners are going to be doing with the language, okay? What are they going to read? What might they have to write? Or what are they going to discuss in groups, that type of thing. Now, there are two challenges at the text level for students, which are really significantly beneficial to highlight for them and to make visible for them. And these are both text structure and text density. And I'm going to explain both of those and then provide some strategies that might help work with these two things. Okay, so first, to understand text structure, we really need to begin with an understanding that the process of doing science occurs as students attempt to make sense of the natural world around them, right? And they do that by using language, okay? They do that by describing things, constructing explanations, asking questions, carrying out investigations, reporting observations, analyzing data, etc., right? And each of these communicative functions in this list here uses a different text structure to communicate meaning. Okay, so let's see what we mean by that. So for example, if I'm going to describe something, if I am to describe the digestive system, then I would need to start with a general statement, introduce what I'm describing, and then I would follow it by a description of each part of the digestive system and their functions, right? But conversely, if I am to compare something, say I'm going to compare the different types of clouds, I would start with introduction of what I'm comparing, and then a systematic analysis of the similarities and differences. Okay, now the way these two texts organize their meaning or their content is really quite different, right? And oftentimes these communicative structures are not made visible to our students, and they are left on their own to try to figure out what is the purpose, what is going on, how is this organized, okay? So to make it more complicated even, sometimes the texts or the activities we have might have different types of functions and purposes, more than one. For example, in a lab report, you might have hypothesis, methods, and findings. And this will require learners to use language to predict, to explain, to inform, right? And all of those three things get done through a different text structure, okay? You also want to be aware that some of the texts that you have your students read, these too might have multiple functions within them that can cause confusion. To be aware of that. Okay, so how do we support? Well, one thing, and I think this is a real important thing to get across here, is that prior to reading a text, you can significantly reduce a learner's cognitive load by first explaining the function or the purpose of the text, and then two, explicitly showing the students how the text is structured, okay? So for example, in setting up this text here, which you do not need to read, right? But you would want to inform your students that they will be reading an explanation of how honey is made, okay? Then you can visibly share the structure of the text and have students label its parts on their own text. It begins by identifying what honey is, and then it is going to tell you 5 different steps for how honey is made, and ends with the closing statement. And that's not the 6th step, it's just the closing statement, okay? Now you can further scaffold by pointing out the text markers that indicate where each step begins and how students highlight these on their own texts, as shown here in yellow. Because setting up a text like this, in this way, does not take all that much time, right? But it will significantly free up space for learners to then instead focus on meaning, okay? Because they don't have to be wondering and figuring out what is this all about. They know how it's structured, they know what it's going to give them and what they have to read. So it really does help them tremendously, okay? So let's move on to text density. And as science teachers, I know you all know what density is, But the density of a text is not referring to how long a text is, but rather to the sheer amount of volume or volume of information that gets packed into smaller and smaller texts, okay? And probably when you're thinking of your own science teaching, the texts aren't really long. They're smaller texts that students are reading, but they are really dense and complex. And the result can often lead to really abstract, difficult texts for students to read. Now, there are two features of language, again, that contribute abundantly to text density in science that are important for you to understand, but also that your students can understand this. And they are nominalization, which is a big word, but then also long noun groups. Okay, so let's look at these two things. Nominalization is really simply a process that allows the writer to create these really abstract, complex words, technical words. And at a basic level, it's the process of turning a verb or an adjective into a noun. Okay, so for example, we have this here. React becomes the reaction, okay? Or to combine something actually becomes the combination. This is something is thick, now we have the thickness, okay? So the verb into a noun. Now, by using nominalization, the writer can really economically summarize a whole concept, a whole sentence into just one abstract word, okay? So for example, the word reaction can indicate the whole entire process of combining two hydrogen molecules with one oxygen molecule to produce water, right? And what makes that even more abstract is that that word reaction can refer to something completely different in a different context, right? Just like with combination, it might mean one thing in this context, but something different in this context, okay? So these can be really tricky words for our students. The second one is the long noun groups. And for this one, to explain this, I just want you to listen to a scenario. So all you have to do is listen right now. But I am having problems. This is my scenario. I'm having problems with my intestine. And actually, it's my large intestine. And yesterday, the doctor said that it was inflamed, right? And I went to her because I was having regular issues with it, not just once in a while. It was going on for quite some time. And it was making my whole abdomen really painful and achy. Okay. So now that entire scenario that I just gave you can be packed into one singular noun group by writing, I have a chronically inflamed and painful large intestine in my abdomen. Okay. Now, hearing me talk about that scenario first probably allowed you to unpack its meaning, more easily. However, in science texts, students are often confronted with these really long noun groups without any background support. They don't get any, right? I'm going to give you two examples here from Key Stage 3 science curriculum. The first comes from a textbook, and the second is from an exam. And I've underlined the long noun verbs or long noun groups for you, so you can go ahead and read these now. Okay. So that you probably get what I'm trying to talk about now, these big, long things that are really difficult for learners to unpack. Okay. All right. So how do we support? And again, here, the first thing we can do is explicitly teach learners about these language features that are characteristic of science language. This will provide them with some control or knowledge over how that language works. And students will also really regularly benefit from having you highlight these features and discuss them in the context of the lesson that you're teaching. In addition, students will also benefit from unpacking these in everyday language, right? Like we talked about earlier, in discussions and that type of thing, through everyday language, building up their meaning. And since both of the features are nouns, it's easy to discuss their meaning by asking questions like what, where, when, how kinds of questions. So here we can see for nominalization, like with reaction, you might ask students to talk about, well, what reaction are we referring to? Combination, what is being combined? Unpack these for them. Where is the large intestine? Because it's in the long noun group there, it tells you, okay? You can also have learners do this in groups themselves, okay? So you can give them a long noun group, say, or a sentence here, each biome has a distinctive combination of life forms. That's the long noun group. But then you might ask them, can you draw what that means, right? Can you tell me what that means in your own words, that type of thing. You can also have groups for fun, create their own long noun groups, right? And see which group can come up with the largest. And this is a nice way, I mean, even to kind of maybe summarize a lesson or a unit by having them pack all that information that they know about something into one long noun group, and you're working with both content and language together there, okay? So that is at the text level, text structure and text density, and we're going to move on now to the sentence level. We're going to look here at, again, sentence structure and passive voice. We'll see if we have time for passive voice. I'm keeping my eye on the clock. But first, just like the text, what we saw earlier about how texts have different structures based on their purpose or function, so too do sentences, okay? They have different structures based on their purpose or function. So for example, when describing the digestive system, then those sentences are going to be using a lot of descriptive words. Compared to comparing items, like clouds will require sentence structures that allow for a comparative analysis. Okay, cirrus clouds are different than stratus clouds because, okay? So we can see that there is language that is used to compare and to contrast. A and B are alike because, or the difference between A and B is, right? One similarity is. There's language used to predict, right? Most likely A will happen because. Combining A and B should cause, and so forth, okay? Language used for classifying, some, all, most, right, is used for classifying and procedural language sentence structures. Next, after 20 minutes, first, then, that type of thing, okay? Now, for learners developing English, they may not necessarily have developed these types of sentence structures yet, which can really be a barrier to communication. They may know exactly what they want to say in their heads. They may know the content, but they don't have the structures yet for saying it, okay? So in this way, the idea of using sentence frames can really be of support. And the thing is, though, is that you would want to provide a sentence frame that actually does match or use what you want your learners to do with that language. For example, here, if you're wanting them to explain the steps of how to make honey, you would need to provide sentence frames that actually allow for that sequencing to be made, okay? Which will be different if you're asking them to compare something. And I have seen where we provide sentence frames that do not match what we are asking them to do, okay? So just a simple warning, though, as well here is to be mindful as how often you use these, because you do not want to use them if it's going to limit language use of your learners, okay? Because learning a language just requires you to practice and try things out and to mess up and to take risks and all of that. So you don't want to over scaffold. But if they're really new to English and you can provide visuals or word banks or that type of thing, can also really help. Okay. Now, I am going to pass over, well, I'll do passive voice really quick. Hopefully we'll still have time here. Okay, another characteristic of science discourse is that it sounds really authoritative. And it's just because it's a real objective kind of field. We're not really into this subjective thinking with science. And students are going to need to sound like science experts when they write or be able to read this kind of authoritative language. So how does that work? It's also. So I'm going to have, at the sentence level, I'm going to have you read this sentence first. Okay, and we will see here that there is a lot of focus on the subject. I, my, me, my, that type of thing, right? But now we can turn this sentence into a much more authoritative sounding sentence in this regard here. Go ahead and read it. Okay, and what's happened here, and this is what passive voice is that we've taken away the subject here, and instead we are focused on this object of logical development of ideas, right? It's not my ideas or I'm going to develop. There's that nominalized word there, development, instead of I'm going to develop, right? So we've taken away the subject and we've put that object in the front. And learners who are used to more of a simple sentence structure of subject, verb, object will really find these tricky when we no longer use the subject in the sentence. So again, to support, the science has so many of these, it would be helpful to show students how this works. People destroyed thousands of acres of animal habitat. Well, now we're going to start with that thousands of acres of animal habitat. That's what we're focusing on, the object. We have to say now were destroyed. And then we can put the subject by people later. Or we could also just not have any by people or subject at all. Okay. So again, to try to unpack these, asking questions, who destroyed those thousands of acres of animal habitat? How do you think they destroyed them? That type of thing. Okay, so just to be aware of this, we're trying to get rid of passive voice a little bit in the academic field because it just doesn't necessarily need to be so authoritative all the time, but just so you're aware of how it works. Okay, and finally, to wrap up, one last thing for the word or phrase level. And I know all of you are probably quite good at teaching those technical vocabulary words, but I'm going to look at another difficult feature of vocabulary and talk about multiple meaning words in science, because science is packed full of them, and researchers have really picked up on this as well. And here's some examples that I want you to read so you know what I'm talking about. Okay, now those are multiple meaning words, and Alice Dykman has also done research on the linguistic transition of students as they go into secondary school. And she interviewed a number of children and asked them, what makes science hard? And this is what Ellie said. Okay, and Ellie went on to explain that it was hard to understand what was going on because she always thought that concentration meant to think hard. Okay, and she couldn't figure out what they were talking about. And your learners are going to be drawing upon all of the language that they know and that they understand. And if they don't know the scientific context for that word, it's going to cause a lot of confusion. Okay, so highlighting these multiple meaning words and recognizing them and addressing them is going to be really important. However, I know what can be difficult for teachers is that we might not even be aware too much of these multiple meaning words because we are so often used to using them in the context of science, okay? But I guarantee you, if your students don't know what you mean or what these are in science, they're going to be thinking of a whole lot of other things in their head. Is it pie? Are we talking about fireplace, even though mantle is spelled differently? Are we talking about apples and pears? That kind of thing, okay? Now, one way to make something that is confusing and maybe negative for students is to turn it into something positive and empowering to them and saying, asking them to be the ones to come up and to find these multiple meaning words because they probably will recognize them much more than you will too. So, but be very aware of that because that is something that comes up a lot in science. Okay, so, as we end up here, I just want to say that we know that there's a lot of challenges in scientific language that can honestly be overwhelming. And you might honestly feel too that it's just enough to focus on your content. I get that. And yet, if we just can focus on one or two language features at a time, then over time, language awareness and the development of this language will build up not just for your students, but also yourself. Okay, so start one step at a time. Try to find one of those long noun groups. think about a multiple meaning word. Try to structure a text for your learners so that they have more space to think about the meaning of it. Because as teachers become more aware and knowledgeable about language of science, as they start to address and highlight challenging language features, right, at the text, sentence, and word level, and as they begin to use strategies to scaffold language demands, such as highlighting and modeling and explicitly teaching, then it will be learners like Karima, right, who will no longer feel as if science is that secret language that she has to really figure out on her own, okay? So in closing completely, I just want to say we too also have further resources for you at the Bell Foundation. These will come to you, the links for these will come to you in the follow-up email with the recording. We have strategies called Great Ideas, lots of strategies there, teaching resources, which include lots of visuals and collaborative activities to use and language-focused supports and that type of thing, as well as highlighted practice on EAL and science. A great video there too of just where you can see a teacher actually really focusing on language in science and scaffolding that for her learners as well. Okay, so I think that's it. I will go ahead now and finish or stop sharing myself.
Well, thank you so much, Sheila and Yasmin. It's been really packed with useful information. I don't think we had any questions during, but Yasmin, you mentioned the survey that ASE are conducting amongst teachers at the moment. Would you like to tell us a little bit more about it?
Yes, of course. So I hope I alluded to the fact that we interpret inclusion very broadly, and this is a subject that is quite topical in schools for all number of reasons post-pandemic. So we've had a highly successful series of CPDs that was DFE funded, and we're extending upon this work and really responding to what schools are telling us, and we're trying to expand our offer on how we support schools. And so with that in mind, we do want to get as much feedback from schools as possible so that we develop things that are of benefit to schools. And so yes, please do, if you don't mind spending 5 minutes at some point this evening, please do fill in our survey, and we will use that to shape our future programs that are coming up, in the not too distant future. And as you will have seen from the links already shared by Shalka, do sign up to stay in touch with us, and we will let you know about what we've got coming up with regards to all of those areas of work. So yeah, thanks Shalka for reminding me.
No,
And
thank you.
And thank you for posting. So you've just see up on your chat, you've got our survey link. So it's 5 minutes, not too long, hopefully easy to do.
And we will also include it with the email that we'll send up together with the recording, just in case someone has had to leave already, or they want to do it a bit later. So well, I think I can't see any questions, and there weren't any during the webinar. But I would just say that we will share all the links, as had been mentioned, including the links that Sheila has mentioned and the link to the video of a science teacher teaching a lesson. And also, if you want to find out more about how best to support your EAL learners and explore some adaptive teaching strategies that you can use in your lessons, we have an online course coming up in September, on the 17th of September. You can register on our website. You can always sign up to our newsletter as well if you want to be the first to hear about our online courses or further webinars. And as quick reminder, we will send out the follow-up email within 48 hours of today. You will receive a recording of the webinar, all the links and resources that we mentioned today, and also a link to an evaluation form that we would be grateful if you could complete. So
I think there is a question in the chat that I just noticed whiz past.
Is it
about linguistic analysis?
Linguistic analysis.
So I think the question.
Yes, I see. Are there linguistic analysis help sheets like what Sheila has just presented? Was a question. Can you think of?
I don't know what is completely meant by linguistic analysis sheets. Are we think? I don't know if that person is still there that can kind of give us a little bit more description of what they are talking about. I know there's been a lot of work done with, you know, with the language of science, but I don't, in terms of looking at things at the text level, sentence level, word level, that type of thing, but I don't know about, I'm wondering if they're talking about comparative analysis or, okay, to help sheets, more for other subjects. I don't really know if I know but if it's vocabulary or the types of sentences that I don't have anything off the top of my head that would just be a sheet that we could hand over to you on that one. I don't know, Yasmin, if you've ever seen anything in science like that.
The only thing I can think of is, and you'll find examples of this on the STEM Learning website, is examples of how we can scaffold the text. So not so much linguistic analysis of existing text, but linguistic analysis of how we want students to, let's say, write a prediction or write a conclusion. So we're giving them a breakdown of what the sentence structure would look like, to help them scaffold how they would give a sufficiently sophisticated answer. So yes, there are scaffolds for those. And I think, was it Amy? I'm not sure if what you're asking is, were you requiring linguistic analysis of text, pre-existing text, to show how it's breakdown? So I think that's where potentially we were confused.
And I guess I don't know of actual sheets for that, but I mean, I think there's a lot of work out there. I could think of things where it's really talking about language and content, that type of thing, where you're really getting a understanding of, I think it comes out of more of the systemic functional linguistic field, where they're really looking at the purpose of what you are, what the language is being used for. And then from that, they come down to really looking at how then the structures go along with that. So it could be for all different types of genre. And we do have some, I could send you some, a sheet that we do have a resource on that at least lists that, like for information reports, what kinds of sentence level structures you might be looking at compared to the text structure, compared to explanations or procedural language, or maybe that's what they're talking about there. So we could maybe put a link to that in the resource that we send out tomorrow. But I'm just trying to, that might be what we're talking about a little bit more.
Yeah. I think we've got examples from other subjects, because Amy did mention other subjects as well in some of our training materials, but I think we need to have a think to see what is freely available. But I think if you can include what you've just mentioned, the links. And
some, well, I have more books, but not just a sheet, which people don't have time to read a whole book. So we'll provide some things in the email tomorrow for sure.
Great, thanks, Sheila. Yes, and I was looking at the chat. I can't see any other questions, and I know that many people have already had to leave. So that brings us to the end of the webinar. Thanks again, Yasmin, for your contribution to the webinar. It's been a real pleasure having you here today. And thank you, Sheila, for speaking, so in detail about linguistic inclusion and the demands of science. I would say to the participants, if you've got any questions, if they come to you later on, feel free to drop us an email as well, and we will get back to you. So thank you very much for taking part in today's webinar, and we look forward to seeing you again soon.